Lab Guy here. You're probably wondering what's taking so long on the Chief project. Why are my videos so far apart? Well, as you know, I have shared with you that I've had trouble understanding all of the factors involved in horizontal scan circuits. I am getting a handle on that. For the past about a week or 10 days, I've been extremely sick. But I'm better now. I'm getting much better now. I was basically stopped by internal pain from a muscle strain or a tendon strain in my ribs. I'm recovering. The pain was excruciating. I could barely move. But I'm getting over it. I guess I stood up and turned just right, twisted something. That's life. So, today we will continue with the issues involved in the horizontal scan section of the Chief, and I will show you what happened and why it was initially working and I was feeling really good and making really good progress. And then all of a sudden, out of the blue, the darn thing stopped working. I hadn't changed anything. What do you think that could have been? This is the current circuit, no pun intended. One of the earliest mistakes I made was I thought that you drive the bottom transistor with horizontal drive directly from a sync generator. This is not the case. It is driven with a 50% square wave, more or less. The transistor turns on and current flows upward, negative current flow, through the yoke, through a current sensing resistor which will be removed in the future, or not. I may use this as my scan failure sense resistor, up to the power supply. When the switch is on, current flows and the ramp starts at the middle and starts up. When the drive wave turns on and when the drive wave turns off, when the drive wave turns off and the transistor opens, the field around the coil collapses and creates a very high voltage negative spike, which is absorbed by this diode. At this point, the capacitor begins charging. That discharge point is right here. Then the capacitor begins to charge until we get halfway and the switch turns on again. And now the current begins to flow, which picks it up at the 0 point in the center and continues on, and the cycle repeats. Imagine a DC line through the middle of my crappy waveform here. So this is negative current and this is positive current in this coil. This is the essential operation of the circuit. Now, the capacitor, what is its function? The function of this capacitor is to set the shape and fall time of this edge. This is half of a sine wave. Think on that. And if that's half of a sine wave and it completes in the 10 microseconds of blanking period in the video, and it has to be complete when it reaches the bottom by natural resonant ringing of this L and this C. That's pretty good. And so if we were to extrapolate this wave into a continuous sine wave, it would have a period of 20 microseconds or a frequency of 50 kilohertz. So, this capacitor is chosen to resonate with this inductance at about 50 kilohertz. Now, this can vary a little bit depending on other parasitic values in here. Parasitic capacitances, inductances caused by lead lengths, especially ground. Ground will eat this thing alive. If these leads are more than a few inches, or even a few inches, too much. The peak currents in this thing are in the amps, even though the average current drawn is less than 25 milliamps in this test circuit. So, what has happened is that the high voltage spike may be short. This is a fast switching diode, fast recovery diode. I bought a resistor substitution box and a capacitor substitution box and an assortment of capacitors at the time, and I hooked the substitution box here and would dial it in to resonate that edge, and it worked. It worked beautifully. It worked for a while and then abruptly stopped working. Who can guess why? Ooh, pick me. High voltage spike killed the capacitor box? Yep. The capacitor substitution box is an Elenco CS440. I should rehearse better. And I've already opened it up. It's nicely built. It's a good product. I'm not knocking the product in any way, shape, or form. If you do electronics and you're working at reasonable voltages, this is a perfectly good product, and I highly recommend it. You can find them online for $30, or you can buy them over the counter for about $40. I also bought the matching resistor substitution box, which I've yet to use and which I haven't burned up yet. But give me time. Be patient. Give me time. All right. So, looking inside, you can see we have our switches, two 12-position switches, the bank select, which side do you want to use. We have the low value side and the high value side. Today I will be repairing the low value side because this is where the resonance was occurring. All of these capacitors are stressed. They test good at low voltage, but they do mess up when I put them in my circuit. So I will be removing all the little capacitors and putting brand new ones in. I purchased 2 kilovolt ceramic capacitors for this job, and fortunately they're all small and they will all fit. Now you'll note the box that there's not much clearance. This is the inside height of the board when it's bolted in the box, so the parts have to be smaller than that. What would happen if I wanted to replace this side, which is the larger values? Well, that's very simple. I'll mount them to the back. The inside of the box behind here is a good that deep. So I've got plenty of room to put the higher voltage caps. Now this leads to an interesting thought. You buy this for $30. You turn around and buy a $12 kit of high voltage capacitors. And I will admit something here. I bought these from Amazon. I swore several years ago to never spend another penny of my hard-earned money on that website. I won't go into the reasons, but I have my principles and I will stand on them and leave it at that. So a friend of mine actually purchased these for me, though I did pay for them. So we have a 2 kilovolt kit of capacitors that will replace every value in the substitution box. So this will be done by, of course, removing the capacitors and putting in the new ones, and then putting the box back together. I'll spare you watching me struggle with the labor of doing this, but this is the explanation of where we are at. And when this is repaired, in the next video, I will pick it up with the actual circuit in operation, and we will once again try to resonate that falling edge and see what happens. Lab guy out.